morning, everyone. I hope you are doing well this Wednesday morning. Are there any questions you'd like to discuss before I start the lecture? Okay, here we go. Today I'm going to continue with the endocrine system, and hopefully get to the integument in movement, or I will first discuss the muscle and the skeleton and then proceed to discussing skin. I don't think there will be enough time for everything today because a lot from the last lecture we did not cover, and it's some interesting stuff about the hormones and the glands that produce those hormones and how hormones affect our body. So most of the lecture today is going to be focused on the hormones and the glands. First, a couple of reminders. We have quiz 5 that is that is open and due on this Friday, February 26th, before midnight. So be sure to complete it. As I mentioned before, it's kind of a week of two quizzes. The quiz 4 was due on Monday, and quiz 5 is due on this same week on Friday. Now, quiz 6 opens immediately after, and it's opens at midnight on February 27th, and it's going to be due on Friday, March 5th. And we have a short participation assignment that is due today, and it's focused mostly on hormones. Now, last lecture I ended on the posterior pituitary, and I mentioned that the posterior pituitary gland, which is located, let me pull up my laser pointer here, which is located below the hypothalamus. We have a pituitary gland, and pituitary gland consists of the two parts: the posterior pituitary, which is not highlighted in this image, and anterior pituitary, which is highlighted in yellow. So remember, the posterior pituitary produces two hormones. Does anybody remember what those hormones are? Oxytocin, and I see ADH. Yep, that's exactly right. And ADH stands for anti-diuretic hormone, which means, if you've heard of diuretic pills, diuretic means like to expel water. Diuretic pills stands for like pills that expel water from the body. Anti-diuretic is would have the effect that retains water in the body. So anti-diuretic hormone affects the kidneys in a way that the kidneys do not expel water. They return water back to the blood. Okay, and oxytocin is responsible for the human bonding and reducing stress, and something else that I'm blanking on, but you can refer to the previous lecture. Now, anterior pituitary, unlike the posterior pituitary, it secretes much more hormones. It secretes six hormones, and the activity of the anterior pituitary, and by activity I mean hormone secretion, is regulated by the hypothalamus here. Okay, so the six hormones that are produced by the anterior pituitary are our old friend TSH, which is thyroid stimulating hormone. We have five new ones. We have GH, or growth hormone. We have prolactin, ACTH, which is adrenocorticotropic hormone. You don't have to know the translation. You just need to know what it affects. FSH and LH, which stands for follicle stimulating hormone and luteinizing hormone, and finally endorphins. So growth hormone, as the name suggests, it promotes growth and development of all tissues. Okay, so it affects most cells in the body. A quick note. Note that all of the hormones secreted by the anterior pituitary are water-soluble hormones. Like all of them are protein or peptides, and which means that all of them are water soluble. And because they're water soluble, they have a relatively fast effect on the cells, unlike the lipid soluble hormones, which produce a bit of a delayed effect, because the lipid soluble hormones, there's much more steps involved in how lipid soluble hormones would elicit a response from the cell, because there's the lipid soluble hormone has to get inside the nucleus, has to affect the messenger RNA, then synthesis of the messenger RNA, then messenger RNA would have to exit the nucleus, attach to a ribosome, produce a protein, and then that would be considered a response, okay? But that's a bit of a reminder from the last lecture. So growth hormone affects all of the cells in the body and affects human growth. The prolactin is the hormone that stimulates milk production in mammary glands. So unless there is a suckling infant's prolactin release is repressed by the hypothalamus. But certain medicines that can stimulate the prolactin, and even, in fact, even men can get milking, can experience the side effects of producing milk from some medicines. So TSH, as we discussed in the previous lecture, it's a thyroid stimulating hormone that literally stimulates the thyroid gland to produce the thyroid hormones. So ACTH, which stands for adrenocorticotropic hormone, it stimulates the secretion of metabolic hormones from the outer portion of the adrenal gland. FSH and LH, or follicle stimulating hormone and luteinizing hormone, stimulate the testes and ovaries to release the sex hormones. And finally, endorphins are natural pain relievers. They affect the brain. They affect some nerve cells in the brain in the region that is responsible for pain. And because the alleviation of pain brings pleasure, endorphins can be pretty addicting. Well, we feel good when we release endorphins. So a fun fact, heroin and morphine bind to the same receptors as endorphins, and that is why they are incredibly addictive. Because endorphins do not flood brain in such quantities naturally. So whenever a person gets addicted to heroin or morphine, it's because they receive an extra large portion of the endorphins from the heroin and morphine, or opiates in general. And it's incredibly hard to get off those drugs because naturally a human body cannot produce that much endorphins that are supplied by those drugs. All right, so any questions so far about this? Moving on. So pituitary abnormalities can affect body size. So they get under or overproduction of the growth hormone produces abnormally small or large individual. This here in this picture, you see Lavinia Warren, born in 1841, and she was 81 centimeters in height. Okay, then 81 centimeters translates to roughly 32 inches. And that's how tall she was at the age 20. So she had pituitary disorder, and the pituitary disorder caused the underproduction of the growth hormone, and Lavinia. That's why Lavinia was so short. And as opposed to like the pituitary disorder can cause the abnormally large individuals, okay, abnormally high growth. And this here is Robert Wadlow, and he was 2.7 meters high, which is 9 feet high. And it is a very tall person, 9 feet tall, I should say. So Robert Wadlow died in 1940 at the age of 22. So people who have overproduction of the growth hormone, they usually die at a younger age because they grow too fast and their heart cannot keep up with supplying all the tissues with blood and oxygen. Okay. So thyroid glands, the thyroid gland sets the metabolic pace. The thyroid gland produces two hormones, the thyroxine and triiodothyronine. So triiodothyronine, usually called the T3 hormone for short. And they increase the rate of metabolism in target cells of all tissue types. So the second hormone that is produced by thyroid is called calcitonin. So both hormones are water-soluble hormones, so they will have a fast effect on the cells. And what calcitonin does, it affects, excuse me, it's it affects the building of the bones. So calcitonin is responsible for sucking the calcium out of the blood and putting them into the bones. I'm using figurative speech, so somewhat here, but for instance, if there's not enough calcitonin, then bones will not be built as tough. The bones will not be strong because calcium is responsible for mineralization of the bones to make them hard. So the abnormalities of the thyroid gland are usually called hyper or hypothyroidism. Hyperthyroidism indicates the overproduction of the thyroid hormones, and hypothyroidism indicates the underproduction of the thyroid hormones. So if a person has hyperthyroidism or overproduction of the thyroid hormones, the person will have too much thyroid hormone thyroxine, and the physical effects of too much thyroxine is unintentional weight loss, the rapid and irregular heartbeats, anxiety, tremor, protruding and bulging eyes. So if you are suddenly sweating at night and have a regular heartbeat, the doctor will likely test the thyroxine and thyroxine content in your blood to rule out the overactive thyroid gland. So the hypothyroidism symptoms are kind of the opposite of the hyperthyroidism. These symptoms that the thyroid is underactive include fatigue, depression, increased sensitivity to cold, weight gain, puffy face or like water retention, hoarseness, thinning hair, and bad memory or worsened memory. So the reason for a hypothyroid could be, well, there are various reasons, but one of the common ones is that antibodies can attack the thyroid and reduce its production of the thyroid hormones. So, and calcitonin, calcitonin is very important during the young age when a person grows and actively builds the bone tissue, but it's less important in the adult age when we have our bones formed and which is fine. Any questions about the thyroid gland and its hormones?
Christine, which ones are you talking about?
The thyroid hormones are water soluble, Christine.
Okay, yeah.
Okay, thank you for the question.
Can you say that most of the hormones we're learning about today are water soluble?
Yeah, they're going.
Okay.
Most of them are going to be water soluble.
I was gonna say I thought you said that earlier.
All right, parathyroid glands control calcium levels, and as the name suggests, the parathyroid glands, they are located by the thyroid glands. So the parathyroid glands secrete the hormone that is called parathyroid hormone, or PTH. Pretty easy to remember. So what does the hormone do? The PTH, the effect of the parathyroid hormone, or PTH, is basically, it releases calcium from the bones and enhances calcium absorption in the digestive tract and kidneys. So calcium, it is kind of the opposite effect of the calcitonin. The PTH and calcitonin have the complementary opposite effects. The calcitonin removes calcium and puts it into the bones, removes calcium from the blood and puts it into the bones, and PTH removes calcium from the bones and puts it into the blood. Okay, so it's complementary opposite, well, not, well, complement, sorry, the opposite effects. Those two hormones have opposite effects. So why is it important to remove calcium from the bones? Why would the body do that? The reason for that is that calcium is very important for muscle contraction, for blood clotting, bone formation elsewhere, activities of many, and it participates in building and reactions with many enzymes. So excess PTH, too much PTH production by the parathyroid gland may cause a disease called osteoporosis, which usually people in the old age suffer from. So the osteoporosis is the disease where a person has less dense and hollow bones that break easily. So a person with osteoporosis is at higher risk to break their bones, and it can get pretty severe. Like a person can just stand up from the bed and break something. So adrenal glands coordinate stress responses. The adrenal glands are located just above the kidneys, at top of the kidneys. Okay, and each adrenal gland has two regions: the adrenal cortex, which is the outside of the adrenal gland, and adrenal medulla, or the inside of the adrenal gland. So medulla kind of sounds like middle, and that would make it easier to kind of remember and visualize. If you just come over the adrenal medulla without an image, you can envision, okay, that's the middle of the adrenal gland. And adrenal cortex is a word for, would be translated as the bark. So cortex is the bark, basically, of the out. If you know if you know what bark is, which is the outside, it's the skin of a tree. Okay, so the cortex is the outside of the medulla, this skin, quote unquote, of the adrenal gland. Okay, so the two parts of the adrenal gland produce different hormones. The adrenal medulla secretes epinephrine and norepinephrine, and these guys are water soluble, amine hormones, which means water soluble. And the target cells for those are blood vessels. And the adrenal cortex, or the skin of the adrenal gland, produces two steroid hormones, or lipid soluble hormones. So these include mineralocorticoids and glucocorticoids. And mineralocorticoids affect the kidneys, and glucocorticoids affect all of the tissues in a human body. So I have a question for you. The hormones of which part of the adrenal glands will have faster effect? The epinephrine and norepinephrine, or the mineralocorticoids and glucocorticoids?
Epinephrine, because it's water soluble.
That's exactly right, Dylan. Thank you very much. So steroid hormones have a slower effect on the target cells compared to amine hormones, because amine hormones are water soluble and steroid hormones are lipid soluble. Great. So adrenal medulla regulates short-term stress responses. So epinephrine and norepinephrine are the acute stress hormones. So by the way, epinephrine is the same thing as adrenaline. Okay, so if you are carrying around an EpiPen for your allergies, and epi in the EpiPen stands for epinephrine, you're literally carrying a shot of adrenaline with you. So why does EpiPen help against the allergy attack? Because if you are severely allergic to something, you can eat something or inhale something, and your tissues start to swell up, it becomes hard to breathe and the person can suffocate from a severe allergy attack. So EpiPen helps to, well, kind of saves lives. It helps the person not to die from the throat closing up. So why does it do it? So the epinephrine increases heart rate and blood pressure, dilates airways, so the breathing rate increases, and increases the metabolic rate and slows digestion. So the helpful part during the allergy attack is this one. It dilates the airways, so the breathing rates can return to normal, okay? Or the breathing can become possible again. During the allergy attack, the airways kind of close up, and adrenaline or an epinephrine widens it back out. As a side effect, you have a racing heart and you feel very alert after injecting yourself with an EpiPen. All right. So the adrenaline, the epinephrine and norepinephrine, you can feel them when you do some extreme sports, for instance, or you get scared, extremely scared of something, or of whatever you're scared from. I don't know. You encounter a bear in a forest. You secrete a lot of epinephrine and norepinephrine, of course, if you're scared of the bear. If you jump with a parachute, there's a lot of adrenaline that will be secreted by the adrenal medulla, and you will feel the effects, immediately. So the adrenal cortex, it produces these slow stress hormones. So the adrenal cortex, it tends to the overactivity of the adrenal cortex tends to elevate the levels of cortisol in the human body. And the cortisol is a stress hormone that has a long-term effect on the body. So it's a chronic stress hormone. Cortisol is useful. It helps control the blood sugar. It reduces inflammation around the body, and it helps with memory formation. But high levels, they induce high levels for a long time. They induce anxiety and depression, and they end up suppressing the immune system. Now, what else is important here? So technically, adrenal cortex produces mineralocorticoids and glucocorticoids. Both of them are steroid hormones. And mineralocorticoids, they maintain the blood volume, and glucocorticoids, they increase the glucose synthesis, constrict the blood vessel, raise blood pressure, and suppress immune system. So cortisol is a glucocorticoid, okay? There is another glucocorticoid hormone called prednisone, and it's often it has a medical use, and it's synthetic. Oh, I'm sorry. Prednisone is not produced by the body. Prednisone is a synthetic hormone that is used to reduce inflammation, but it suppresses the immune system. So prednisone is another example of glucocorticoid, but it's not synthesized by a body. It's rather synthesized synthetically, and it's used in the medical field. So moving on, are there any questions about the hormones I covered so far and their effects? Okay, pancreas. Pancreas regulates the blood glucose, and glucose, remember, is the same thing as sugar. Glucose is a simple molecule of sugar that is used for energy. So the pancreas secretes two hormones, insulin and glucagon. Both are peptide hormones, meaning they're both water-soluble hormones. They have a very fast effect on the target cells. The target cell of the insulin are basically all of the cells, because insulin helps metabolize sugar, and all of the cells basically need sugar, so all of the cells will be affected by insulin. But glucagon hormone, it only affects the cells in the liver. And the reason for that is that liver stores the polymer of glucose called glycogen. So the polymer of glucose that we know already are cellulose, and I think you know one other polymer called starch. So cellulose and starch are both like complex molecules, the building blocks for which are glucose. And glycogen is the like similar to starch, is analogous to starch, but starch is accumulated only in plants and glycogen is accumulated only in animals. So glycogen is stored in the liver, and glucagon, this hormone secreted by pancreas called glucagon, it affects it basically breaks down the glycogen stored in liver into glucose molecules to feed the body, to provide the body with glucose. So insulin, there's a negative feedback in the body that causes release of insulin or glucagon under certain conditions. So the negative feedback basically regulates the energy in the body or energy availability in the body. Let's say we have normal blood glucose concentration, and normal blood glucose concentration means that all of the cells in the body have enough energy to function. And remember, glucose is needed, by the way, all of the cells in our body need energy to function. So why would glucose be needed by all of the cells? Does anyone remember what are reactions that need glucose to happen that would provide energy? It seems you guys are sleepy today.
Is
Middle
it
of the
cellular
week.
respiration?
That's exactly right. Thank you, Joshua. So cellular respiration needs glucose. And what is that first step that breaks glucose into smaller molecules, which are then used in Krebs cycle and in and in other steps of the respiration? Like, what is the first step? What is the glycolysis? Thank you, Anel. Glycolysis is the actual reaction that breaks down that takes in glucose and breaks it down into smaller molecules that then enter further reactions within respiration, heterotrophic respiration. Excellent. So when we eat food, for instance, high glucose food like a chocolate bar, then suddenly our blood glucose or blood sugar concentration becomes too high. In response, the cells in the pancreas, they sense this high blood glucose concentration and release the hormone called insulin, which helps the body to take up the glucose for storage or the use in the metabolism. And as a result, blood sugar concentration decreases and becomes normal again. So the sugar that is in the blood, with the help of insulin, it can either be stored for use later or used up immediately by the cells in the cellular respiration reactions. If we go without food for a long time, we feel hungry. We feel like we need glucose in our blood, but we don't actually die from hunger for a long time. So why is that? And one of the reasons is that whenever there's low blood sugar, when there's a low concentration of sugar in the blood, the pancreas cells sense this low concentration and release the hormone called glucagon. And what glucagon does, it affects the liver cells and prompt the breakdown of the glycogen, the polymer, the large molecules that consist of glucose building blocks. Okay, so these large glycogen molecules are broken down into smaller glucose molecules, and these glucose molecules then enter the bloodstream, providing other cells within the body with glucose. So insulin and glucagon kind of have the opposing effects on the blood sugar. on the blood concentration of sugar in the blood. Any questions about the negative feedback? Hopefully it is clear how this feedback can be classified as negative. All right, moving on. So probably you've all heard about a disease called diabetes, and diabetes is characterized by too much glucose in the blood, too much sugar in the blood. So in diabetes, the body cells are starving for because of the lack of glucose, even though there's plenty of sugar circulating in the blood. And as well as urine. So you pee out this sugar, there's plenty of sugar in the blood. You may eat sugary foods, but the cells still starve. The cells cannot use up this sugar. And this kind of situation is characteristic for diabetes. There are two types of diabetes, type 1 diabetes and type 2 diabetes. And in type 1 diabetes, the cells in the pancreas are destroyed and cannot produce the insulin. So people must inject themselves with the insulin in order to use up the sugar that is ingested with food. Now, in type 2 diabetes, the pancreas is fine. The insulin is present, it secretes insulin, but the cells across the body become resistant to the insulin. So this form of the disease is impacted by diet and exercise. Usually if you change the amount of sugar, of simple sugars and complex sugars in your diet, you can control the symptoms of the type 2 diabetes. So can anybody guess or deduce why high blood sugar is bad? What are the possible consequences? What could be possible consequences of high blood sugar?
Stroke.
Ooh, Joshua, good guess. But I'm not sure stroke is like a direct consequence of the blood sugar. I was hoping you would connect that bacteria love sugar, and our body is full of bacteria. There's bacteria in our gut. There's bacteria everywhere. Okay, we just are not freaked out about them because often they're beneficial to us. But sometimes they can turn on us, and bacteria love sugar. Okay, and the bacterial overgrowth can cause infections. For instance, let's take another example. When you cut yourself, okay, cut a finger or a toe, and if you have normal blood sugar, your immune system will kind of fight the infection off faster and heal the wound. The bottom line, it will heal the wound. But if the blood sugar is high, then bacteria will multiply faster. They will feel very good in the wound that is with the constant supply of yummy sugar, and your immune system will not fight off the infection at a sufficient rate compared to, because of the bacteria, they are growing too fast. Okay, and as a result, diabetics or people with high blood sugar content, they're more prone to infections that go out of control.
I had a pure curiosity question. Does high sugar level in the blood affect the thickness of the blood in a way that would be harmful? Like
I am not sure. I do not have a definite answer to the question, but it is a good one.
Okay.
I'll look
Yeah,
it up.
it was a bit random.
After the class. All right. So what some other consequences besides the risk of infection and the wounds not healing and going out of control, like the infection spinning out of the control, other effects of the high sugar in the blood is basically there's an effect of the nerve cells. the nerve cells do not send signals as fast from one to another. And this may cause the loss of sensation in the limbs, particularly in the feet. There's this phenomenon called diabetic neuropathy, which is basically people lose sensation if they have high blood sugar for a long time. But of course, there's a way to manage it. If a person suffers from type 1 diabetes, they inject themselves with insulin, and if they suffer from type 2 diabetes, they can manage their diet and exercise in order to control the level of the sugar in the blood. My grandma is frankly diabetic, and she acquired type 2 diabetes when she was about 50. Right now she's 80. Let's see, 84. Healthy, nice. She's controlled her diet and exercise for 34 years, and she feels great apart from being 84 and old and tired. Okay, so Salvador, can any of these go away, or once you have it, it's forever? So if you have type 1 diabetes, it's forever. But if you have type 2 diabetes, in some cases it can be reversed, particularly if you have pre-diabetes, so-called quote unquote pre-diabetes. That's one of the classifications the doctors use. You can reverse it if a person is overweight and has a high sugar diet. Changing the diet and losing the extra mass of the body can reverse the pre-diabetes. If you have type 2 diabetes, sometimes it can be reversed, but usually it's for life.
I have a question.
Yeah, go ahead, Brandy.
So in like pregnancy, I know that it's called like gestational diabetes. Would that be considered type 2 because it can go away?
I am not sure. I did not take this into account, and I don't know about gestational diabetes at all. So I'm gonna look it up and follow up with you guys. So gestational diabetes and the blood thickness and sugar. I'm gonna make a note. Thanks for the questions. They're great.
I actually just looked up because I was curious about the gestational diabetes. I don't think that it falls into the category of type 1 or type 2, but it does say that if you have gestational diabetes, that you have a higher chance of developing type 2 later on.
Thank you, Ansley. Does that address the question, Brandy?
Yes, thank you.
Okay, any other questions? Okay. Now, pineal gland, switching gears from the insulin and the pancreas to another gland. So this gland is one of my favorites because I love sleep. So pineal gland is the gland that regulates sleep. So pineal gland secretes the hormone called melatonin, and it's a water-soluble hormone which has relatively fast effect on the target cells. And the target cells for the melatonin are other endocrine glands. So the melatonin is a hormone that regulates sleep-wake cycles, and it starts being secreted by the pineal gland in darkness. Whenever it becomes dark, the pineal gland recognizes, ooh, it's time for sleep, and starts secreting melatonin, which then affects other glands. And if in the morning its concentration it becomes low again, and amazingly, even if your eyes are closed, but there's daylight, it's daylight, and in your room, it's light, it becomes light in your room. The brain still senses that it's light outside through the closed eyelids, and the melatonin production is reduced. So high melatonin levels tell the body that it's time to sleep, and low melatonin levels, conversely, tell the body that it's time to wake up. So a few fun facts. Probably you've heard, well, if you live in Florida, maybe you have not heard about it, but I'm from the north, And there's this widespread condition called SAD, or seasonal affective disorder. And it's actually been linked to the overproduction of melatonin. So like people are constantly sleepy and are not as active, and they become depressed. So it's the SAD, or seasonal affective disorder. It affects people living in the northern latitudes where days are short during the winter. So what I'm used to basically is that what I grew up with is that when the sun rose in the winter, the sun rose at like 8:30 a.m. and set at 3:30 p.m. And these low light level conditions, they kind of they do make people constantly sleepy and hungry, paradoxically. So I'm looking at the question, how can I reduce melatonin level? Basically expose yourself to the light conditions. When you wake up in the morning and it's sunny, go outside and soak up that natural morning light, and you will feel that you become more alert and kind of perky. And that's because your melatonin level goes down. And yeah, if you don't have access to the natural lights, then there are like these daylight lamps, special lamps that you can that you can turn on and kind of look at them. And it's a way to deal with low light exposure in the northern latitudes. It's a big industry there. So I have a comment about living in Alaska, and someday the sun would not come up. Yeah, Alaska is like above the polar circle, right? So it's it can be nighttime for like the whole day, or rather dusky situation for the whole day. There was something else I wanted to mention about this melatonin. Oh. So you may not, if you're young, you may not feel the effect I'm going to talk about next for very extremely, but as you get older, it will become more apparent. So to increase your melatonin levels at night, it is recommended that you don't stare at your phone or any other screens before going to bed, because the screens emit the blue light, and blue light is interpreted by our brain as daylight. So if the brain experiences daylight, if you're lying in bed reading, I don't know, social media, Twitter, or if you're on Facebook or whatever your social media of preference is these days, you will have a harder time falling asleep because your brain constantly gets a signal that, oh, it's daylight. It's not the time to go to sleep yet. So you may turn off your phone and just lay there for an hour or another hour or 2 hours waiting to fall asleep. And your brain will just refuse to shut off because it was just exposed to the daylight. It doesn't understand that it's nighttime yet. Or it takes time. It takes a couple of hours for it to understand that it's nighttime and it's time to secrete melatonin and put you to sleep. I have a question. Do blue light blocking lenses work? Anyone know? Yes, they do work. So there are special glasses that you can put on that filter out the blue light. And actually you can adjust your screen settings on the phone or on the laptop. For instance, I adjust my screen settings about 7 p.m. if I'm working on my laptop. After 7 p.m., the screen color spectrum on my laptop changes. It filters out the blue light and the colors get funky, but I'll tolerate that for the opportunity to go to sleep in time.
I was going to ask, you said earlier going out in the sun can help reduce levels of melatonin. Does also the creation of vitamin D assist in energy levels? Like, do they work together to kind of like wake you up?
Vitamin D has a slightly different pathway, but it does increase your energy level, and it helps make metabolism more efficient. But it's not really connected to melatonin. So the sunlight decreases the melatonin levels, and sunlight also affects the vitamin D levels because the vitamin D is synthesized in the skin under the presence of sunlight. they're not really connected. The only connection is both are affected by sunlight.
Yeah, that's what I kind of meant.
Oh, okay. Oh, you got muted. I thought you were going to say something else, but you are.
No, I was just saying that the link that I was discussing was only the sunlight, not that like melatonin and vitamin D are connected anyway inside the body.
Yeah, you're absolutely right. So I'm going through the chat here, and if you have a question, just unmute yourself and feel free to ask it. Amal asked about melatonin supplements and whether they decrease natural production. And I see Ansley answered it, and the answer, I agree with the answer. Yes. So usually melatonin supplements are, from what I know, it's not recommended that you take them for longer than 2 weeks because it does exactly that. The body learns that, oh, I don't need to produce melatonin anymore, so I just won't. Okay, there's a question about prednisone. Why is prednisone used in medicine while it suppresses the immune system? Good question. So whenever the body overreacts to an infection or something else, or not even an infection, but I'm going to give another example. So there are diseases that are called autoimmune when immune system attacks the body's own its own body. Okay, the immune system attacks its own cells. Or the cells within its own body. And it's not good, okay? You get inflammation just because you have skin cells, or you get inflammation just because you produce insulin or something like that. You know, you don't want this to happen. This is like not comparable with living sometimes. So prednisone is given to people with such autoimmune diseases to reduce the inflammation so that they can live more comfortably and not die prematurely from their own bodies attacking itself. Okay, moving on. FSH and LH, or follicle stimulating hormone and luteinizing hormone, regulate the ovaries and the testes. So they basically stimulate ovaries and testes to produce male or female hormones. And this is the summary of the slide. I'm going to speed it up a little because it's 10:17. So hormones from the ovaries are stimulated by FSH and LH, and there are two hormones produced by the ovaries, progesterone and estrogens. Both are steroid hormones, which means lipid-soluble hormones. Now, progesterone affects the uterine lining, hypothalamus, pituitary, and other tissues, and estrogen affects the same, basically. Both hormones have both target cells, which are in the uterus and in the brain, and the pituitary gland. And testosterone is also a steroid hormone. Sorry, I'm going to move here. Testosterone is also a steroid hormone, which means it has somewhat delayed effect compared to a water-soluble hormone. Steroid means lipid-soluble. And testosterone promotes sperm development and maintains secondary sex characteristics in men, which are basically facial hair, deepening of the voice, increased muscle growth. They are all effects of testosterone. And synthetic forms of testosterone are used to increase sports performance often. However, if the drug stops, it may cause infertility because the body stops producing own testosterone. So if you are into doping for the sports performance and your doping of choice is testosterone, please be careful and don't do it. And especially not, always consult a doctor, and don't use doping because it can, it can backfire. So I'm going to go back here because there's 1 minute left, and I treated the progesterone and estrogen unfairly by skipping straight to testosterone. So progesterone regulates the menstrual cycle and prepares the body for pregnancy, and estrogen regulates the menstrual cycle as well and maintains the secondary sex characteristics in women. So the secondary sex characteristic in women are basically wide hips, large breasts, more hair in different places compared to men. And there's also, interestingly, some testosterone produced in the ovaries, but it's not nearly as much as is produced in testes. Okay, there's a little bit of time left for questions if you have any. So any last minute question, guys? So did I answer your question about prednisone? I didn't see any. Okay, great, thank you. Okay, and if there are no questions, thanks for joining, guys, and I will see you on Friday.